Professor Clements with you as we consider in astronomynotes.com elements of chapters 1, 2, and 3, how we perform science to discover how the universe works, and in a follow-up video, celestial sphere. This video just talking about science. So let's go ahead. The scientific method, there are many different statements of the scientific method, but I would break it down into 3 parts. First, someone makes some observation, collecting various observations from people in their own experience, looking for trends in how phenomenon occur, and classifying and organizing those observations so they can be thought of in an organized way. So we make some observations. Then looking at those observations and trying to make statements that explain them, explain the trend that takes place, given that one quantity changes, another quantity is observed to change. We make a hypothesis. We make a statement. This is our best explanation as to why the observations are occurring, why the phenomenon's happening the way that it is. So we make this statement a hypothesis. Then we must perform a controlled experiment in some manner to try to disprove the hypothesis, to test it. You may think that's pessimistic, but that's the way science works. We cannot do an experiment that will prove a hypothesis. We might have just had a special case. So we do experiments over and over to try to disprove the hypothesis. If those experiments cannot disprove the hypothesis, then that hypothesis may become accepted. If there's consensus that the experiments were done well, the hypothesis can be accepted and be a theory, and if it's a kind of a general theory and is applicable to a lot of situations, might move in to be called a law. But scientific method, 3 parts to it: making observations, making a hypothesis, and doing a controlled experiment. And controlled in such a way that you don't have a lot of things changing. Try to isolate it just to what the hypothesis is trying to predict, and do it in a controlled way. Just one variable is preferred. So this hypothesis, to be scientific, it must be testable. We have to make a statement where we can create an experiment. So what about this statement? The sun shines because it is on fire. Yes, that's testable. We can look at the light from the sun and determine if it's combustion that's taking place. We can look at the elements that are on the sun and see if they're able to combust, and they're not. So the sun is not shining because it's on fire. The sun shines because of nuclear reactions that release energy near the center of the sun. That's a hypothesis. It's testable, and there are certain particles called neutrinos, we'll study later, that can be observed that left the core of the sun and then detected at the Earth. The sun shines because it is bright. Doesn't really fall in the category of a testable hypothesis where you could create an experiment. So you might think of your own here, but hypothesis, we must be able to create an experiment. So scientific method, you might get a little piece of string, hang a little weight to it, let it go back and forth, change the length, let it go back and forth and see how the period changes, the time to go back and forth once. Put different objects on the string, change the mass, change the initial release angle, and see if you can observe any effect on the period from one of these 3 variables. Then write a hypothesis that explains, given, for example, that the length increases, the period increases. Or you might say, given that the mass increases, the period increases. Or you might say, if the angle is larger, then the amount of time to go back and forth will be larger. So you write a hypothesis. And then you would test that. Well, you would test that by keeping, if you're testing the statement about the length, you would keep the mass and the release angle constant while you varied the length. Or if your hypothesis regarding the mass, you would keep the length and the angle constant while you change the mass on the string. So you would do that, and we may do that later in class. I won't give it away, but if you're curious, try it on your own. Be a scientist. So what value does astronomy have to science? Well, astronomy provides a great laboratory for the people on the Earth. They were considering problems that involve very low vacuums. Space has that it's difficult to create that on the Earth. Large gravitational pull. The Earth has some gravity, but there are situations where scientists would like to know how the world operates, how the universe operates with much larger gravity force. Astronomy can provide those conditions. Or very high temperatures, higher than anything on the Earth, or very high pressures, again, higher than anything on the Earth. And by observing matter in the universe, astronomers can help physicists better understand how the universe works. The value of astronomy also applies in that as astronomers look at more distant objects, they're looking at the past. If some galaxy is 2 million light years away, the light in that galaxy left there 2 million years ago. And astronomers can get an insight as to, have the laws of physics changed over time, or are they constant? And it appears that they are constant. We can observe how the universe works at various locations in the universe. Is the Earth and the Sun in a very special part of the universe where the laws of physics are different than at some other part of the universe? It appears not. It appears the laws of physics are the same all throughout the universe. But astronomy really expands the realm of conditions that scientists can explore and have data on. What about astrology? Is that a science? Some people will tell me, ask me, what's new in astrology? And they really know that I teach astronomy, but they'll misspeak and say astrology. So astrology is, it's an ology, and making statements based on configuration of the planets. And I'm not an expert on astrology because I don't follow it. It predicts human tendencies and future events. What about astrology? Well, we would say it's not a science. It would be called a pseudoscience. It claims, to be able to predict things, but if you would do experiments and do surveys, you'll find that it's not predictive. It does not match what, the outcomes don't match what's predicted. However, the astrology has provided us the zodiac constellations, and they are important in astronomy. The zodiac constellations are those constellations, basically, where the sun moves through in a year. And this has changed a little bit. The sky shifts over hundreds of years a little bit, and so the path of the sun on the sky is not quite the same as it was a couple thousand years ago. But we still refer to the zodiac constellations, 12 constellations. The sun, moon, and planets move through these constellations. So they are useful to talk about, but I do not read the paper daily and look at the astrology predictions because they don't work. What about the concept of a correlation? Something might be talked about to be correlated. If they change at the same time, they're correlated. Does that mean that one caused the other? For example, is the price of corn the prime factor in determining the price of soybeans? And the answer is no. It's the amount of acres of soybeans that have been planted, and if that goes up, the acres of corn go down. Or did they both get rain? And if rain comes at the right time, the price of corn can drop, and also the price of soybeans will drop, as both crops will have a bigger harvest. So just because two quantities change at the same time does not mean that one causes the other. Again, we need a controlled experiment to explore that hypothesis. So that's the place where we're going to stop in this video. Again, we have the concept of the scientific method. We want to take out general observations, then form a hypothesis, and then take data in a controlled experiment. So that's the way that science knowledge advances, and we build upon previous work, and as new technology comes along, we can make different experiments and test different hypotheses. So good visiting with you. Read over that material and ask questions.